All right, week 3 of distance learning, we are going to take a look at how to tell which types of conic sections you have based on the formulas in standard form, and then also when they're not in standard form. There's a nice little way to use the determinant to figure that out. So standard forms, these are all the different types of equations we've looked at so far with circles and parabolas, ellipses, and hyperbolas. It's all of them that we're going to look at in this unit, but that's really all there are of the conic sections anyway. So circles, there's only one standard form, and then the other three all have the dependence on which axis is the major axis, so the longer of the axes, or if it's just orientated horizontally or vertically. So this first one here, we want to write the equation in standard form, so we're actually going to change it from whatever form it's in to standard form, and then figure out what it is, and then graph it. So here, we do have a couple things that are squared, so y squared and an x squared. So that right there kind of tells us that it's probably not going to be a parabola, just because parabolas only have one thing squared. So we can go ahead and mark out parabola. But the other three, it could be any of it. Kind of just depends on how it looks. So what we want to do is get it into some kind of standard form. So we know that we need, for any of them, to have our x's and y's all on the same side. So we need to add 2x squared to both sides. So we end up with 2x squared plus y squared equal to 18. So at this point, we could have a circle, but we have that 2 out front of our x squared, so we don't want that to be there. So what we could do is just divide everything by 2, and maybe that would be it, but the fact that we have the 18 on the other side doesn't really work, because if we divide everything by 2, we end up with a fraction. And we know that if we have a fraction, we either have an ellipse or a hyperbola based on the standard form for those. But both of those have to be equal to 1. So instead of dividing by 2, we need to divide everything by 18. So we're going to divide by 18 on all three terms. Sorry if I'm sniffling this time. My allergies have been really beating me up lately. 2 over 18, that's just going to be 1 over 9. We leave the y squared over 18 as it is, and that's just equal to 1. So that is our equation. Now we know that we have a plus in the middle, which means that we don't have a hyperbola, and because we have fractions, so fractions get rid of the circle, and the positive makes it an ellipse. So now we're ready to go ahead and graph it. So we have it in standard form. There's our equation. We know a couple things about it. So our A is the square root of 9, or 3, and b is the square root of 18, which is not a perfect square, so we do need to figure out what the square root of 18 is. So using a calculator, we get that we know it's over 4, because 4 squared is 16, 5 squared is 25, so it's somewhere in between there. It's about 4.24. So we need that to be able to graph it, and so about 4 1/4 going in that direction, and since it's under the y, that's going to be up and down. So that's going to be about 4 1/4 up from, and there's nothing being added or subtracted from the y or x, so our center is the origin. And then our a is 3, so in the x direction, since that's under the x, we go both directions 3. Now we can go ahead and draw our ellipse. And something like that. So now, classifying conics with the discriminant. So the discriminant is b squared minus 4ac, but with conic sections, the only one we've really seen the discriminant with before is a quadratic, and that's what a parabola is, and that's great, but we haven't really seen that with anything else, so we have to actually figure out what that means. So I thought I added it in, I guess I didn't. So here is what that looks like. Let me go back. So it's that b squared minus 4ac that's in all 4 of these. Oops, I thought I was writing on was on. Alrighty, good. There we go. Production value. B squared minus 4ac when you have an equation in this form. A squared sorry, that should be ax squared. Ax squared plus bxy plus cx cy squared. There we go. We'll get it sooner or later. Plus dx plus ey plus f equal to 0. So now, again, it's b squared minus 4ac, so really, this stuff doesn't matter. We're really only focused on these here. So whatever is with the y squared is your c, whatever is with x squared is your a, and whatever, if there is something that has an x and a y together, that's your b. So we got to keep that in mind when we're doing these problems here. So these ones, we're not going to change these to standard form. We could do that. We could add the 9 to both sides and then divide by 9, and that will tell us kind of where we're going with it. I just told you kind of we're going to have to divide, so that eliminates parabolas and circles right there. But we're not going to do that. We're going to ignore the fact that we could do that, because if we use the discriminant, it tells us a few things. It tells us exactly what we're looking at, right? So here, our a is going to be the thing with x squared. So in front of x squared, it's a minus 1. So negative 1 is a. There is no x, y together, so b is 0. That's common. It's very rare you'll have that in a conic section, or really at all. And then for c, that's what's in front of our y squared, which is 3. So now we need to calculate our discriminant. So b squared minus 4ac, so that's going to be 0 squared, minus 4 times negative 1 times 3. 0 squared, 0, so that just goes away. And we have negative 4 times negative 1 times 3. Negative 1 times negative 4 is 4. 4 times 3 is 12. So now, what we need to do is take a look at some things. So we go back to the last slide again, one more time. And it tells us some things here, right? So the first one for circles, if our discriminant is less than 0, so it's negative, and b is 0 and a equals c, then it's a circle. If it's less than 0 and either b is not equal to 0 or a is not equal to c, then it's an ellipse. If it's equal to 0, it's a parabola, and if it's greater than 0, it's a hyperbola. We just got 12. So 12 is much greater than 0. So this means we have a hyperbola. So I didn't have to turn it into standard form. The reason this really exists, it's not so bad for that first problem, but this next problem would be difficult because we have an x and we have a y outside of our x squared and y squared. So we'd have to complete the square twice. In order to get that in a standard form, it's a lot more complicated to do than just doing this discriminant process to figure out what the shape is. So again, we have a, b, and c. Again, a is with x squared, that's just a 2. There's no x times y in this at all, so b is still 0. And then we have a c that's in front of our y squared, which is also 2. So we plug everything in. B squared minus 4ac. So again, b is 0 minus 4 times 2 times 2. The 0 squared goes away, it doesn't do anything. And we have a negative 4 times 2 times 2. Negative 4 times 2 is negative 8. Negative 8 times 2 is negative 16. Now, we had two different possibilities whenever it was negative or less than 0. A circle or an ellipse. So here, if it's less than 0 and b is equal to c, or sorry, a is equal to c, they're both equal, right? A equals c is true. And b is equal to 0, which it is, so that's true. Then we have a circle. If one of those was false, then we'd have a ellipse. But because they are both true, we do have a circle. So our last one here, I hope it's kind of obvious what this could be because we do only have one thing being squared. But again, this is kind of just to show you that we could go ahead and get it into standard form. Again, we wouldn't have as much of a hard time as we would have had with B, but with C, we'll just go ahead and run through the process. So A, B, C. There is no x squared, so that's a 0 for A. There is no x times y, so B is also 0. And there is a y squared, but it's 1 in front of it. So, again, B squared minus 4AC. 0 squared minus 4 times 0 times 1. 0 times anything 0, so the 0 squared is gone like it has been. But now the second part, negative 4 times 0 times 1, it's times 0, so that's gone too. So we get 0. It's equal to 0. That means it's a parabola. Not too bad. It's just a nice way to be able to tell right away, like without doing any extra work, without doing any manipulation to the actual equation, what shape you're looking at. And that is it for these notes. See you next time.